Let's see, always check your fly. Okay, fly's closed.
Hi, my name is Eric Johnston, and I'm an aviation photographer. Join me as I document all kinds of aircraft from big to small and cool to, well, really cool. This video is proudly sponsored by Air Models. Check out their excellent variety of resin and die-cast aircraft models with over 400 commercial and military aircraft and helicopters available. Click the link in the description to see more from Air Models.
Welcome, my name's Rene Dugas, and I'm the very lucky owner of a Turbine Legend. I'm also partners with Aileron Roll, who also owns half this aircraft. We've had it for about 12 years. I have a little over 400 hours in it, and it's just a delightful aircraft to fly. We're fortunate enough to have a 730 horsepower Walters engine in it. It's a turboprop. That kind of power gives us a climb rate of almost 6,000 feet a minute. It's a home-built aircraft. We built it in a garage and hangar down in Winsboro, Louisiana. I'm a CFI, and I get to teach in other aircraft. Since this is experimental, I don't get to teach in this airplane, but I do get to fly it quite a bit. Usually I'll fly at altitude because it's a jet engine. I like to fly higher because it burns a little less fuel. This thing does drink about 35 gallons an hour at about 330 miles an hour at 17,000 feet. Down low, it drinks a bit more. I do race it in the Air Venture Cup race most years, and have had some luck. There are some planes that have more horsepower, and you just can't overcome horsepower. So I get to win second or third most years and have a great time with those guys, and just enjoy the experience. This aircraft is made of double wall carbon fiber with honeycomb in between. It weighs empty up just over 2,000 pounds. It has about a 1,300 pound useful load, so you can carry quite a bit of fuel, 2 people, and about 90 pounds of luggage. It has 140 gallons of fuel, 100 in the wing and 40 in the tank behind and below the rear seat. It has an auto start system that makes it much easier to start. It stalls at about 68 knots straight ahead. It, as I say, climbs at almost 6,000 feet a minute. It's rated at 6 positive and 3 negative. Our engine, the Walters 601D, is not rated for inverted work, but it can certainly be rolled, and we do loops and rolls in it often, and it's just delightful. It just does big aerobatics, big smooth aerobatics. An aileron roll in this thing involves pulling up to 20 degrees and just roll it over. It's about a 4-second roll, and very smooth, usually at about 220 to 240 knots. It's, once again, very light on the controls and just delightful to fly. It does, when it stalls, it does have about a 2-inch stick shake, so it's very obvious you're about to stall. And to get out of a stall, you push the stick about 1 inch forward and you're out of the stall. We have a good burble on this elevated horizontal in the back that gives you a very definitive stick shake. It's just a great warning. The kit comes with the fuselage is 2 halves, side by side. The bulkheads are put in. The wing comes with top skin, bottom skin, and spars. You put in the separate ribs. It's built in a jig, and it's all one carbon fiber spar, so it's very strong. The Walters, the exhaust is in the front. It's a reverse flow engine, so the air comes in through the Naca scoops on the nose, comes through and enters the engine in the back. The ignition occurs and the burning occurs going forward, and the exhaust comes out the back. It comes out toward the back from the front of the engine. It has a big beta prop on it that also reverses, so when I land I can reverse the prop blades and actually push air forward, so I have to use very little brake and can stop in about 1,500 to 1,700 feet. So it doesn't require a lot of runway, especially coming in at about 75 knots. The airplane has a very interesting end number I was able to obtain from the FAA, 95007. So I have the pleasure of entering the pattern and saying Experimental Turbine Legend 95007, and after that I'm identified as Legend 007. Just more fun. Ailerons are fairly small, but at the speeds I'm going, the stick force is firm but very adequate. We have a trim tab here and long ailerons, long flaps that do extend down quite a bit, lowering the nose, so on approach you can see the runway extremely well. It does not rotate up so that it blinds you for your approach. We do have a fairly high aircraft, so we have a step built in, so your foot goes in there, then you step on the wing and you enter the aircraft. Our static port is very small. This tiny dot is our static port, and we have a matching one on the opposite side to make the airplane extremely smooth and aerodynamic. The horizontal, once again, has to be very strong for the G-forces that we're able to pull. We did cut it out twice and reinstall it to try and get the angle exactly right to get the amount of downforce necessary on the horizontal to get the plane to fly with the elevator at neutral. It's somewhat, on some aircraft that's difficult to do. You may have to have it up or down depending on the cruise, but we have a low pitch angle wing on this aircraft, so it doesn't require very much pitch. It has a relatively large rudder, but because we have so much horsepower and a big propeller, on takeoff it's important to be careful how much power you enter with the throttle. You can enter so much power that it torque rolls, and there's been a crash that involved that, so we have to be careful. I usually take off at about 65% power. I can take off at 30% power. It's nice to have horsepower. If you'll come around this side, we have a different paint job on this side, but it's actually vinyl. This is to make it look more like a World War II fighter. Some people really like this side. I like the swoops on the opposite side. We have electrohydraulic landing gear with electromagnets that don't attach, but are attracted to this metal plate. So when the gear are up, they are then locked in place with the electrical power of the electromagnet, so I can actually pull G's with a retractable gear aircraft without breaking them. We have a 40-gallon fuel tank underneath the rear seat. Here is an aux tank, and as I said, 100 gallons in the wings. We can continue around. We do have nose art on it to go back to encourage the history of the warbirds. This is not a warbird, but it's so much less expensive than a warbird and has so much less maintenance involved. I've added 3/4 of 1 quart of oil to this Walters engine in 12 years. We've changed the oil once in it. We've had to do almost no maintenance to the engine. There are very few access panels on the aircraft because there's very little to look at. There's very little to check when you're pre-flighting the aircraft. It's just a very, very simple aircraft that goes very, very fast. I like the look from the front. It looks very sharkish. We do have large scoops on the top. Some of the aircraft, the Turbine Legends, will have Naca scoops or ram air scoops under the cowl. When you're climbing out from takeoff, you get ram air from underneath and you can cool the engine slightly better and get a little bit more power. We have the top Naca Ducts. I found that when we were trying to get maximum speed out of this aircraft, that because of this big propeller spinning this way, it's blowing the air diagonally across the nose. And I did oil studies on it and found that about half of this Naca duct was being blocked off, and we were not getting any airflow in there at high power settings. So I added Vortex Generators, 4 of them around the cowl. I found that the other 3 didn't do any good, but this one trips the air coming up diagonally, and it goes into the Naca duct, and it added power with a fuel burn increase of 2 gallons an hour. At race speeds, that's very significant. I gained about 5 or 8 knots top end just by adding this Vortex Generator. This structure is a device we're using to split the air to go over the exhaust pipe, because this is a dead area. When we did yarn testing on the aircraft with a photo ship, we found that this area, the yarn actually was going forward. So we put the splitter on it, and it helps split the air to go around it. A full fairing would be even better, but it makes access to the engine quite difficult, so we did not go that route. We have cool air Naca duct here, and I will show you the scoop underneath, which is actually an oil cooler, and gives it that very P-51-esque appearance. If we can step around the wing again, I'll show you the canopy and the inside of the aircraft. It's a 2-seater, front and back, tandem seat. Inside the plane, this is luggage down to here. The back seat folds forward for luggage, but they're very comfortable, wide, thick foam seats that make the plane very, very comfortable. We do have heat in it. It's not pressurized. I get that question a lot. It's not pressurized, but I can use nasal O2, and I've taken it to 22,000, and it flies perfectly fine up there. Some other owners have taken it much higher, but I'm very comfortable in the upper teens and low 20s. At that altitude, I can get about 300 to 330 miles an hour, burning about 32 to 33 gallons an hour. So a few years back, we installed dual Dynon touchscreen instruments from the round gauges, which were Electronics International. We liked them, but we kept having problems with one of the instruments, so we decided to go flat screen. I'll turn those on, and we can see it fire up. I do have oxygen through nasal cannulas here. We have a fire suppression system in it. I have dual radios with a Garmin 430 and a Becker here with a intercom system. We have 2 panels of circuit breakers that are completely accessible. On this right side, I have a gauge that gives me my hydraulic pressure holding my gear down. They also have over center linkage and springs and gas springs holding the gear over center linkage down. But this confirms that I also have 650 to 700 pounds of down pressure on my landing gear. The Dynon is fired up. The way I usually fly it, I fly it with the engine instruments on the right, my PDF in the center, and maps at the bottom. And can turn on the other radios, which includes the Garmin 430 in the left lower corner. It does have coupled approaches with capabilities for coupled approaches here with this panel for Dynon. We were Dynon's first turbine installation, and they were kind enough to work with us on some of the finer points of monitoring a turbine engine. The Avionics, as I say, it'll do coupled approaches. It has dual AHAR systems, so I have backup. They're separately powered. They're separately backup powered with outside batteries. And they have also have the Garmin 430 and the separate Dynon GPS system, so either one can be used. Although the Garmin is the certified approach, so that I can use its WAS capabilities to do instrument approaches and for monitoring for its position for active ADS-B that is current with 2020 compliance. There's very few switches compared to most aircraft. I have canopy switches. I have two main bats, igniters, fuel pump, start switch. I just hold it 3 seconds and it starts. It has an automatic programmed electronic starting system. All I have to do is give it fuel through the mixture and hit the starter button, and it goes through the whole starter sequence, even if it's hot. If the temperature is over 200 degrees centigrade, it stops the start cycle and you have to allow it to cool. I've only had it do that once, and I hit what's called motor. For those of you who are not turbine users, you flip the same switch the opposite direction. It does not initiate the start cycle, but the starter motor turns the turbine so it blows cool air through the whole engine and lowers its temperature. Then you can hit start and it starts. We've never had it fail. It's worked great. And then you get to go fly fast.
And do the buttons on the stick do anything?
Yes, I have mode switches so that I can do control wheel steering on the left side that ties to the dynon. If I am flying at on a heading of 360 and I want to turn to 330, I don't have to touch anything on the panel. I can just push the CWS button, bank it over to 330 degrees, let it go, and it auto selects and locks at the new course. I can also have the trigger button is for my push to talk. This button isn't connected to anything, and I can change frequencies with this other button. Throttle quadrants is over here. The mixture is like any other on-off kind of mixture. The engine doesn't have a leaning program that is pilot controlled, so I would advance the fuel mixture, then pull it back to its detent right there, and it locks. So I can't turn the fuel off by accident unless I push this other lever, unlock it, and then pull it back. So in flight mode, you pull it back against the stop and leave it there the whole time. The propeller is in feather here. Push it forward for full takeoff at 2020 RPMs, and then pull it back and cruise at 1750 RPMs. Throttle, I can advance the throttle for whatever speed I want. It also has a gate on it at the base, and that's how I go into beta. So I would pull it back to idle, then I would pull up this lever, pull it back, and it goes into beta, and the propeller starts to blow air forward. So I can slow down dramatically. The downside to that is that if you're on rollout after a landing, that disruptive air that's flowing forward can be disruptive to the controls surfaces in the back, especially the rudder. So I might be using 1 inch of travel on my rudder pedals, then I push it into beta, I may have to use 3 or 4 inches of rudder travel to get the same response because of the disrupted flow. It's not a problem once you learn how to do it, but the first few times it's almost like you lost control, and it's just because you're not putting in enough control. And then I'll slow down to about 15 miles an hour. Then I usually slide it back out of beta and taxi off the runway.
Nose wheel steering.
Does not have nose wheel steering. It's differential braking and rudder control, so it's a freewheeling nose wheel, except that it has a system in it that when the nose gear extends and the weight is off the tire, it has a V-like groove that straightens the wheel and fork so that when it rotates up into the wheel well, it's straight. And as I say, this one is all touchscreen, so I can make changes all through it. So I can adjust headings and course buttons, and I can say select whether the sky view is working the GPS, running the GPS, or if I'm going to use my Garmin 430 to drive my GPS for my navigation. I can enter transponder information for code. I would just enter it in these buttons, and it shows my transponder at the top. It works really good. All these instruments also have been delightful. In the Dynon system, you get to design exactly what you want that to look like. You can have circular gauges, you can have bar graphs that I happen to prefer, and you move them around. I moved this one around so that I can make it very compact, so I get the maximum PDF for my navigation.